At North Carolina State University, all first-year engineering students are required to take an Engineering 101 course. In this course they are assigned an engineering project to complete by the end of the year. We are Group 17, Jess Patterson, Joshua Martin, Eric Hayes, Grant Clark, and Braden Carlson. We were assigned the Concrete Canoe project and decided that use concrete or it's your asphalt was a fitting slogan. In this presentation we'll be covering various aspects of the project, including the design challenge, the research we conducted, our initial proposed design, initial testing that we conducted, our final design, our final test, and our results at the FEDD event. The Concrete Canoe project had two main objectives: build a concrete canoe that floats and holds as much weight as possible. However, it wasn't just that simple. For one, the project budget could not exceed $40, although previously owned, borrowed, or found materials did not figure into the budget. The final product had to be made of reinforced concrete, without the reinforcements showing, and it had to resemble a canoe. In addition, there were some dimension constraints. The length could be no longer than 18 inches, the width could not exceed 1/3 of the length, and the depth could be no deeper than the width. Once we understood our project, we continued the design cycle by conducting research regarding why heavy objects float. We found that two related factors have an effect on how an object floats: density and pressure. While concrete alone is obviously denser than water, it is still possible to make it float as long as the total density, that is, the density including the air within the object, is lower. Basically, total density can be defined as the mass of the concrete plus the mass of the air within the canoe divided by the total volume of the canoe. However, what makes density important is the pressure. Water itself exerts an upward pressure related to the mass of the water being displaced by the object and the surface area in the water. The denser an object is, the more downward pressure it creates due to gravity. If this downward pressure exceeds the pressure that the water creates, the boat sinks. After our research was conducted, we generated some ideas and eventually narrowed them down to an initial proposed design. Our initial idea for the shape of the object was to have a flat bottom and sides angled slightly outward. This was to ensure stability. We also decided to use styrofoam to reinforce the concrete because it is lightweight and easy to cut into the shape that we wanted. Unfortunately, styrofoam did not work out too well because it was not strong enough to form concrete around effectively. Eventually, we decided to go with a more conventional reinforcement and use some wire screening. Once we had our first prototype built, it was time for testing. Unfortunately, this test was unsuccessful because the concrete was too porous and allowed water to seep into the canoe and eventually sink it. We fixed the issue by adjusting our concrete mixture. Our final build was composed of 14 grams of Portland cement, 6 grams of sand, and 19 grams of water. Then it was time for our final test.
Yeah, she floats. That is pretty cool.
I see air bubbles.
Where?
On the sides.
Yeah.
Our results at the main event at the McKimmon Center weren't especially spectacular. However, they were decent as our canoe was able to hold an additional 59 grams before sinking, more than what it weighs alone. We may not have won anything, but we managed to fulfill the requirements without any problems. In conclusion, we analyzed our design challenge, researched information to help us with our design, used that information to design our first prototype, tested that prototype, learned from our mistakes, fixed them, and tested one last time before taking it to the design day, where we achieved some respectable results. And here are our references, which can also be found in the description.